A very good morning to everyone. I, Falak Alam, Assistant Professor in the Department of Computer Science and Engineering. I'm going to take your today's session on the topic Monolithic Architecture and its Traditional UNIX Kernel. It is an important concept in operating system. Operating systems are responsible for management in computer hardware and software resources. This we all know. Every computer system, whether it is a desktop, computer, laptop, smartphone, or any other system, it depends upon an operating system to function properly. As we all know, the software system acts as an interface between the user and the computer hardware. And without an operating system, it would be extremely difficult for us to use and interact with the hardware directly. In this lecture, we will focus upon the architecture of operating system, the concept of monolithic architecture, how the kernel works, how the Unix operating system were designed, the components of Unix kernel, the advantages and limitations of monolithic architecture. Understanding these topics will help you to learn how operating system evolved over time and why modern systems are designed differently. Now I'm going to share my screen that will be a PPT presentation so that we could understand it more easy. These slides provide an overview of the topics that we will discuss. In this session, we will begin with operating system basics, where we will understand what an operating system is and what functions does it perform. Next, we will discuss operating system architecture, which refers to the internal design and organization of an operating system. After that, we will study monolithic architecture, which is one of the earliest operating system architecture, where we will understand its structure, characteristics, advantages, and disadvantages. Then we will move on to the kernel concept. The kernel is the core component of an operating system that interacts directly with the hardware. And later that, we'll study traditional Unix operating system, which is a classic example of a system that uses monolithic kernel architecture. And then finally, we are going to discuss the concepts of unique kernel, such as process management, memory management, and file systems. By the end, I hope you will understand how monolithic system works and how Unix implemented them. Now moving forward with the first topic, that is operating system. Now we'll understand what an operating system is. An operating system is a system software that manages computer hardware and software resources. It acts as an intermediary between users and computer hardware. Let us take an example like when a user opens an application such as a web browser or a text editor, The operating system handles many background operations that may include allocating memory, scheduling the CPU time, managing files and storage of the device, and how we communicate with the hardware devices. Without an operating system, users would have to interact directly with the hardware components using complex instructions. Since there is an operating system, so we are using it very easily. Else, we're gonna to have very complex instruction that must be given to the hardware so that we should interact with the system. The operating system simplifies this process by providing user-friendly interaction and services. As I said, since there is an operating system, so it simplifies the process using user-friendly interfaces and the services. Examples of operating system include, like we are using Windows, some of you must be using Mac OS, Linux, Android, UNIX. All these systems manage hardware resources and provide services for the application program. These all operating systems provide us the services for the programs that we do and manage all the resources on the hardware. Now, what are the functions of operating system? The functions of operating system include operating system performs several critical functions. The first function include process management. A process is a program that is currently running. The operating system manages these multiple processes simultaneously. Since it is possible that many of the programs, many of the processes are working continuously. The operating system manages multiple processes simultaneously. It decides which process get access to the CPU and how and for how long. This process is known as CPU scheduling. Operating system does CPU scheduling so that we could get access to the priority task. Like the task that is important, that process will run first. Now moving to the second function, that is memory management. Memory management ensures that each process receives sufficient memory to execute. Since the process is working, we need to have some or the other memory so that the process must execute. It also protects memory so that one program can interface with other programs' memory space. Since each program is having his or her own memory, so the program cannot interface with other program. Operating system ensures this as well. Now moving to the file system management, the operating system organizes data into the files and directories. As we all know, the operating system manages and organizes the data into files and different directories. which allows user to create, delete, modify, and access file stored on the disk. Because of this file management system only, we can easily create, delete, modify the task that we are and the data that is stored on the disk. Now moving with the device management. Hardware devices such as printers, keyboard, hard drives need special programs called device drives. The operating system uses these drives to communicate with the hardware device. The additional devices that are added into the system that are performed in this category, and the operating system performs and manages these devices accordingly so that hardware communication could be smooth. Finally, operating system provides security and user management. This includes user authentication, passwords, access control mechanism that protect data from unauthorized access. Like many of you must be having passwords in your phone. So why it is here, why the operating system does this security measurement? It is just because our data should be protected from an unauthorized access. If we don't want nobody else could see our data, what's inside our device. So the security feature is also performed by operating system only. Now moving forward with why operating system architecture is important. The architecture of an operating system determines how its components are organized and how they interact with each other. A well-designed operating system architecture improves system efficiency, reliability, and maintainability. The more it is well designed, the more it will provide efficiency, reliability, and maintainability. Let us take an example. If the architecture is well structured, developers can easily update, modify individual components without affecting the entire system. As architecture also affects the system stability. If the components are properly isolated, a failure in one component may not crash the entire system. The way it is designed, its architecture, if components are in a proper isolated way, then if any of the component fails, it may not result in the entire system crash. Another important factor is scalability. As technology evolves, operating system must support new hardware devices and additional features. A good architecture makes it easier to extend the system. Therefore, operating system architecture plays a crucial role in determining the performance, reliability, and feasibility of the system. The architecture is very important because the performance, reliability, flexibility, stability depends upon the architecture only. Now moving with the operating system architecture. As we have discussed that why it is important, let us see that what actually it refers to. Operating system architecture refers to the structural design of the operating system. It defines how different components of the operating system are organized and how they communicate with each other. The architecture determines basically 3 points, that is, how the operating system interacts with the hardware. Second, how system services are implemented. And the next, how application access system resources. Different operating system use different architectural design depending upon their goal. Some design focus on performance while other emphasize security and modularity. Understanding operating system architecture help us to analyze how operating system manage complex tasks efficiently. As I said, it defines internal structure of the operating system. The how operating system is internally structured and how the communication between software and hardware is done. Also, it defines efficiency, reliability, and flexibility. Now, moving with the types of operating system architecture. There are several types of operating system architecture, namely monolithic architecture, layered architecture, microkernel architecture, modular architecture, and hybrid architecture. The first type is monolithic architecture. In this monolithic architecture, all operating system services are combined into one large program. The services that we are using over OS, all the services are combined into one single large program. This is how a monolithic architecture is designed. As in this design, all operating system services are combined into a one program. Now moving to the second point, that is layered architecture. In this layered architecture, the operating system is divided into different layers, and each layer performs specific functions and communicate with the adjacent layer. Since the name suggests layered, so the operating system is divided into different layers, and each layer is having a specific function, and they communicate with each other easily. The two adjacent layers can communicate and function as they are needed. The third type is microkernel architecture. In this microkernel architecture, only essential functions remain inside the kernel while the other service run in user space. The important functions would remain in the kernel only, and remaining services would be used in the user space. Now moving forward with the fourth type, that is modular architecture. In this modular architecture, where the operating system consists of independent modules that can be loaded dynamically. As the name suggests, modular architecture. So means the operating system consists of different modules that can be loaded dynamically, and they can if we want, we can combine all these modules and function. Now the last one, that is hybrid architecture. The fifth type is hybrid architecture, which combines features of multiple architecture to achieve a better performance and flexibility. As the name suggests, hybrid, which means that we combine features of multiple architectures like monolithic and layer together so that we could achieve a better layer. It could be possible that microkernel and model should get combined so that we could get a in the result. Depending upon the service we want, we could combine the architecture and achieve a better performance. And that will go in the category of hybrid architecture. Now moving with the monolithic architecture. As I already told you in the previous slide, that monolithic architecture, all the operating services are combined into a large program. A monolithic architecture is one of the earliest operating system design. In this architecture, all operating system components are integrated into a single large program. The components include process management, memory management, file system, device drive, and all these components communicate through their shared memory. All the services run in the kernel space, which means they have direct access to the system hardware. This architecture provides fast communication between components because they operate in the same address space. However, it also makes the system more complex and difficult to maintain. Since all the components are into a large program, so maintenance in this architecture is quite a difficult task. Now moving with the concept of monolithic design. In monolithic design, all operating system services operate inside the kernel. This means that different modules can communicate directly with each other using function call and shared memory. Because of the direct communication, monolithic system provides high performance as components interact directly with each other. However, the system becomes very large and complex, and if a bug occurs in any part of the kernel, it may cause the entire system to crash. Since the system is built as one large executable file, so if a bug in any part may cause the entire system crash. Therefore, while monolithic architecture is efficient, it also leads to less reliable compared to modular architecture. So for large and complex system, monolithic architecture is not suitable. It is efficient, but it is not reliable as the modular architecture because modular architecture is more reliable. Now, where this monolithic design comes from, let us check the historical background. Monolithic architecture was widely used in earlier operating systems. It is because computers had limited resources. Like during in 1960s and 1970s, computer system had like very limited memory, slow processors, simple hardware devices. And because of these limitations, designer preferred simple and efficient system structures. As monolithic system allows operating system to perform efficiently without the overhead of complex communication mechanism, it was used in earlier operating system like UNIX and MS-DOS with the limited resources that are available during the earlier time. Examples of earlier monolithic system include UNIX and MS-DOS. Now moving with the characteristic that what are the characteristics that a monolithic architecture holds. A monolithic architecture has several key characteristics. First, it has a large code base because all operating system services are combined into a single program. So if a large code base is not there, we could not combine the entire program. So, and it would be very difficult to get the whole program into a single one. The next point, that is tightly coupled components. Since the components are tightly coupled, which means that they depend heavily on each other, that the dependency on each module is very high since they are tightly coupled. Direct communication between modules. Third, modules communicate directly using function calls and shared memory, which may result in faster communication. Since the modules are tightly coupled, it means the communication is direct, which results in faster communication. Moving forward with the fourth point, that is high performance due to minimal overhead. The architecture provides high system performance because there is a minimal overhead in the communication. Since there is minimal overhead, so automatically the performance would be high. However, these characteristics also makes the system more difficult to maintain and debug. Now, how the internal communication is done in the monolithic architecture. In a monolithic architecture, different modules communicate directly through shared memory and internal function call. Since the modules share memory and communicate directly, this approach eliminates the need for complex communication mechanisms such as message passing. Because modules operate within the same address space, communication is extremely fast. However, this also means that the modules are not isolated from each other. If one module fails or contains a bug, it can affect other modules and it is possible that it may result in crash in the entire system. Since each module is dependent upon each other, so if a bug in any part, the entire system may get affected by that small failure. Now, what could be the performance benefit for the monolithic architecture? Let's see. One of the major advantage of monolithic architecture is its high performance. Since all components operate within the kernel, communication between services is very fast. There is no need for additional mechanism such as message passing or context switching between different memory spaces. This results overhead and improves execution speed. As a result, monolithic systems are often preferred in situations where performance is critical. As I told you that the components operate within the kernel. So communication is very fast, which means there is efficient CPU utilization, but these monolithic architecture are often preferred where the performance is critical. Now moving forward to the next slide, that is advantages of monolithic architecture. The advantage of monolithic architecture includes like fast communication between modules, high system performance, simple design concept, efficient resource usage, easy initial development, direct hardware interaction, less, less complexity in smaller system. Monolithic architecture often offers several advantages, and most important advantage is fast communication between modules. The fast communication between modules, where all components operate within the kernel since they interact directly without additional overhead. Since there is no additional overhead, the components interact each other very smoothly. And another important advantage is efficient resource utilization. In monolithic architecture, the architecture allows the operating system to manage hardware resource efficiently. And additionally, the initial design is relatively simple because all components are integrated into a single system. Since the design is very simple, it is understood that the efficient usage of the resources is done, and development is also very easy. So there would be very less complexity in the small systems. Despite the advantages, monolithic architecture has some disadvantages too. Now let's overview what are the disadvantages of monolithic architecture. The disadvantages include difficult to maintain large code base, hard to update individual components, debugging becomes very complex and complicated. System crash if a component fails, limited scalability, less modular structure. The major disadvantage include that it is very difficult to maintain. If the system consists of large code base, modifying, updating the system is very difficult and it is very challenging. We could not easily modify or update the changes in the system. And the other more complex problem is debugging it. Like when any of the error occurs, it is very difficult to identify the source of the problem. We could not easily identify the source of the problem, and it is very difficult to identify. And a small bug in the kernel may cause the entire system to crash. So it is very important that each component work properly so that it may not result in the system crash. The scalability is also very limited. Now we'll study what monolithic system is. A monolithic system integrates all functions into one unit, and all the services run together in the same environment. Because the components are interconnected, a change in one part can affect the other part as well. And it was used in earlier operating system design. Since the scalability of these systems is very less, as all the services run together in the same environment and change in one component may affect the whole system. Now moving forward with the structure of monolithic system. Monolithic system usually includes three layers. The first one, user interface layer. Second, application logic layer. Third one, data access layer. And these all three layers are combined into a single executable program. The user interface layer allows users to interact with the system. An application layer processes the user's request. Data access layer manages and stores the retrieval of the data. The first layer interacts with the system. Second, processes requests. Third, manage storage and retrieval of the data. So these all layers combine and work together into a single program. So this is how a task is done in a monolithic system. Now we'll study the kernel concept in the next presentation.